All right, here we go with our last example. So we're dealing with water draining from a funnel, which is going to be a 3D cone-like shape. So water is draining from the bottom of a cone-shaped funnel at the rate of 0.03 feet cubed per second. The height of the funnel is 2 feet, and the radius, let's see if I think that's cut off a little bit. The radius is, at the top of the funnel, is 1 foot. At what rate is the height of the water in the funnel changing when the height of the water is half a foot? So we're going to draw a cone, or attempt to draw a cone. The radius at the top is constant, and so we can go ahead and label that as 1 foot. And then they tell us that the volume is changing at a rate of 0.03. So dV dt is 0.03 feet cubed per second. They also tell us that the height of the funnel is 2 feet. Oop, that is not a vertical quite. At what rate is the height of the water in the funnel changing when the height of the water is 1 foot? So we're going to imagine that this cone was full when it started, and at the moment in time that we are trying to evaluate, the height of the water here is only about, and so I'm going to use h of t again because we're still talking about height in this example. And that height is going to change as the water drains. So we need to come up with an equation that we can use. And so the equation for the volume of a cone is pi r squared h over 3. And so if we're looking, we do have something we can use for radius and something we can use for height. And we also have the constants pi thirds. Now be careful here because as you're moving down the cone, your radius is changing. And so we're actually going to be paying attention to both our r and our h as functions of time. Now this does pose a slight problem for us because when we're taking our derivatives, we don't necessarily want to have these in terms of two different variables. And so what we're going to look for is some way to replace either the h or the r in our function so that we're really focused on one of the variables. Now let's take a look. At what rate is the height of the water in the funnel changing when the height of the water is half a foot? So it seems like we're more concerned with, I just lost my whole picture, with our height for our cone than we are with our radius. So give me a second, we're going to redraw this. And then we know that the radius of the entire cone is 1, and we know that the height of the entire cone is 2. And I'm going to draw the volume of the water is decreasing. So we've got this h of t for this vertical height, and then we've got our moment in time down here. So we've got some r value when the h value is only 1/2. And so we are trying to solve this triangle for the height of the water as it decreases. And we've got actually similar triangles, and this is a little bit harder to see in my picture, but if this is a right angle, we have the triangle formed by the cross section of the entire cone, and then we have the triangle formed by the cross section at the bottom when the height is specifically 1/2. And so here's another right angle right here. And since they're sharing the same angle here, these are similar triangles. And that means we can create a proportion relating the sides. And so that proportion is the height of this triangle down here as h relative to the height of the entire cone is equal to the radius at this exact moment of the radius of the whole cone. And so we actually see that the radius at any moment as this water is draining is going to be half the height. And we can substitute that into our equation. So let's bring back our volume. Pi r squared h over 3. Volume equals pi. Function for r is now h over 2 squared over 3. And we can simplify that a little bit further, just as an h cubed, drop the 2 down into the denominator, or it's actually not a 2, it's a 4. And so we've got pi h cubed over 12. Whew! All right, so here's our volume formula. When we take this derivative, we're going to have dv dt, which we know, and we're going to have dh dt, which is what we're trying to find. So let's color code that. I don't remember what color I had it as before. So we'd like to know dh dt. Let's take a derivative. Volume becomes dv dt. Pi 12ths is just a constant. It's going to stay that way. For the h cubed, we're going to use our power rule. So 3h squared dh dt, get a little chain rule in this implicit differentiation. And then we are solving for dh dt, so we can substitute our values now, or we can simplify, bring everything to one side, and substitute later. And I'm all about rearranging my formulas, so I'm just going to do some simplification here, and I'm going to get that dh dt isolated. So I've got dh dt, and then if you can see it, I've got pi h squared over 4. So I am going to divide this to the other side, which means I'm going to have times 4 dv dt all over pi h squared. And that's just if I'm isolating that dh dt. So let's substitute what we know. We know that the volume of the cone, and actually thinking about this, the height should be decreasing, which means its rate of change should be negative. And since the volume is also decreasing, I think that 0.03 right here should also be negative. And remember, that's going to indicate that it is losing water. So we're going to plug in negative 0.03 over, oh, I forgot the 4. 4 times negative 0.03 over pi h squared, which is 1/2 squared. Go ahead and let a calculator simplify that for you. We don't need to leave that in terms of pi, because it's not going to help us interpret the problem. And so I'm getting that the solution is negative 0.15, and then let's talk about units. So this is how fast our height is decreasing, and so our height is decreasing at a rate of 0.15 feet per second. All right. Oh, I did it again. This concludes the video lesson for related rates. There are questions in Canvas that correspond to each of these examples, so make sure you solve those. Follow-up questions, feel free to email me if you have any questions. When we do our first online lecture, I'll be discussing just a various selection of related rates problems. So check out your MORE assignment, check out your book assignment, and be prepared to ask questions and participate in that discussion.